Good afternoon, ladies and gentlemen. Welcome to another edition of me walking you through some Module 4 lesson examples. This one is actually the Lesson 13 exit ticket here on page 139. So grab your book, grab a pencil, and go ahead and turn there. I need a name for this, so if you have any suggestions on what I can call these as a name or, you know, for me making these videos and walking you through these, please send me an email. Let me know at the next meet what you think you want to name these types of tutorial videos, okay? But what we've been doing is we've been given an equation, and in this particular case, question number 1 is no different. We're given an equation, and what we did in the previous video was we had that equation, we had to fill in the table, and then we graphed it onto a coordinate plane. We did that on paper, and then I also showed you how to put a couple of points there in Desmos and use that online if you don't have graph paper. It's very, very easy, very, very simple. So, what we're doing here with question number 1 is we're using an equation that is very, very similar to one we looked at before. This is not the exact same question from the last video, but it's very similar. The other one was 3x plus y equals negative 8. This one is 3x minus y equals positive 8. And so, what they're asking us to do is very clearly look at what is the shape of the graph that the linear equation is taking. Essentially, what is it creating when we have these points put onto this coordinate plane? And the ones, there's lots of different points here. Some of them are great. Some of them are like this one up here at positive 4, positive 4. That is right where two numbers meet, both horizontally and vertically. They both meet at a whole value. And so when we go ahead to test this, we want to use and take points that are given to us that are where numbers actually meet. We don't really want to use ones like this one. If you look at this one, on the x-axis, this one is in between the 2 and the 3. That's kind of a bummer. We don't know the exact value of that unless we take one of our values and plug it into our equation. Okay, here we know the exact value. We know it's at 4, 4. Here we know the exact value. It's at 1, negative 5. And so when we have those exact values, that makes our life much, much easier when we go to plug those values back into our equation and make sure that it works. Okay? But that's not the question right now. The question is, what is the shape of the graph? And so as we go from here all the way up to here, we should be able to very clearly see that this is creating a line. Okay? As we go from point to point, here to here, we should see very clearly that we are creating a line. And that should make sense. When we look at the word linear equation, we've already taken this into our notes, but when we look at the word linear equation, what word is in there? Line. A linear equation creates a line. And so if we have something that is supposed to be a linear equation, or it's allegedly a linear equation, but it doesn't create a line, all the points don't fall within a line, then that's not really what the graph of the linear equation looks like. Okay? So when we go to take a look at question number 2, now the question is brought up. And it's essentially asking us, these points here, they give us a bunch of points. They give us a lot. You won't always get a lot of points that you will be able to test and plug into an equation. Here, you got a lot to choose from. Some of them, like I said before, are nice and easy. Here we have 0, 3. We've got 4, 5. We've got 2, 4, we've got negative 4, positive 1. Lots of different points that meet at whole values. And then we've got a handful that, don't. So we're not going to use the ones that don't meet at handful or meet at whole values. We're only going to look at a couple that will meet at whole values. So let's pick this one at 2, 4. Let's pick this one at negative 2, 2. And let's go ahead and pick this one at 0, 3. We're going to pick those 3 points. We're going to plug each one of them into this equation here to see if this is true. Okay, once might be a coincidence. Twice, that might be by accident. And third time, the third time definitely tells us that there is a trend. If all 3 of these points are going to work within this equation, then our answer is going to be yes. So let's go ahead and plug these in. This is not something we have explicitly talked about. We're going to plug in both values now. We're going to plug in both our x and our y values. So we're going to start with this one right here. We're going to call that point number 1 that we're going to be plugging in. Our x value is 2, our y value is 4. So we're going to take, this is negative x, so this is going to be negative 2 plus 2 times 4 is equal to 5. Is that true? We need to see. 2 times 4 is 8, plus, now we have negative 2. We need to see if negative 2 is equal to 5, or negative 2 plus 8 is equal to 5. We end up getting positive 6 is equal to 5. That is not true. So we know point number 1, that is not a following point of the graph of this equation. Okay, so we're going to cross that one out. Let's check the other one, 0, 3. Let's give this one a shot. Okay, so we're going to take 0, put it in parentheses, put it in front of a negative, plus, and then our y value is 3, so that's 2 times 3 is equal to 5. Hopefully we can see where this is going. A negative 0 is just a 0, so that's going to be nothing, and then 2 times 3 is going to be 6. 6 is equal to 5. It is not. 6 is not equal to 5. So this one is also not going to work. That's point number 2. Okay, that one's number 1. This one's number 2. Let's label these accordingly, just to be neat. And then let's look at number 3, this point here. I have a feeling it's not going to work, but let's test it anyway. So this one is at negative 2, positive 2. So let's see, we have negative 2, and it's a negative on the outside, plus positive 2 for y, so 2 times 2 is equal to 5. So negative 2 is a positive 2, plus 2 times 2 is 4. 2 plus 4 is obviously 6, and 6 is not equal to 5. That point does not work either. This equation is not represented by the points on this graph. We have very clearly a line here. This line, though, does not correspond with this equation. That's all I got for you. Adios.